Landicho, and this is my presentation on the gut microbiome experiment. The gut microbiome is a group of organisms, microorganisms that live in the gut of another organism. They take over a host. Both can be either human or animals, more specifically in this experiment, animals, and more specifically, dogs. And they live within the organism as a community. So, microbiomes usually help with the digestion of the organism that has them, and it also can help with just the overall health that the animal experiences throughout its life. One physiological correlation with microbiomes related to a disease would be with inflammatory bowel disease. They found a correlation with the numbers of microbiomes and the overall effect that inflammatory bowel disease had on the organism. There was a causal relationship that found that the more microbiomes within the body of the animal had a pro-reaction to the inflammatory disease, reducing the side effects of it. A second physiological disease with the correlation with microbiomes would be irritable bowel syndrome. They found that having an imbalance of microbiomes within the body can create a disorder with irritable bowel syndrome, causing heavier reactions to the body, creating more increased reactions or side effects from the illness. This also having a causal relationship. So the question we asked here was, will gender have an effect on the microbiome? And on our hypothesis, we said that gender causes no difference in the gut microbiome. So in our experiment, we tested 4 dogs, 2 of them being female, 2 being male. One male was German Shepherd, 7 years old, about 98 pounds. It had average exercise, and its overall health was average. It ate dry food for its main consumption and food source. The second male, being a pit bull, it was only 3 months old, 20 pounds with good health, high exercise, and it also ate dry food. So that's 2 dogs. Our third dog was a female. It was a French bulldog, 7 years old, with good health, high exercise, and it ate dry food as well. And the last female being a Chihuahua, 3 years old, at 6 pounds, had average health, intermediate exercise, went out every once in a while, and had its main diet source was dry food, and these were all household pets. So here's our protocol. These are all the little steps we took step by step, but the 3 main actions we did in the experiment was isolating the DNA using the chitin kit. When we used the chitin kit, we followed the directions step by step to extract the DNA from a sample of feces from each dog. Secondly, we normalized the DNA with a spectrometer, and then using a qPCR, quantitative polymerase chain reaction, we multiplied the genome to identify what microorganisms we could find in the microbiome. During quantification, we used a spectrometer with measurements of A260, and for purity, we used A260 over A280. With those numbers, depending on the results, 1.8 to 1.9 was good. Anything less than 1.5 was contaminated with protein, and anything higher than 2 had contamination of RNA. Now in our experiment, we tested 3 different phylums, Bacteroides, Firminites, and Varicombia. I'm sorry if I am butchering those names. But in our experiment, we found that we had results that each phylum there wasn't a high enough amount of bacteria in our experiment. So, in conclusion, with the numbers that we got some antibacterial numbers. So, comparing the samples, the genders did not differentiate as much in the analog against one another. Except in the antibacteria, the boys appeared to have a higher chance of having bacteria in the microbiome and compared to the girls. When comparing antibacteria and bacteria, the boys seem to have a higher reaction, but it's not by much, a very minimum number. So it more or less supported our hypothesis, saying that gender didn't really have an effect on the gut microbiomes except for the antibacteria. Now in the future, for our experiment, we could probably pay more attention to the phylum we chose, because like bacteriides, that is the main bacteria found in all organisms. It's usually bacteria that has the highest number, unlike the other phylums, like Phromomites and Vercombia. There's a lower number. That could have been a reason why we couldn't find a significant amount of bacteria within the feces. Thank you.